Alright, let's start at the beginning. Number one, average velocity and average speed. Everybody got that. Velocity, technically speed is just distance over time. Remember the catch, like on UA, if it asks you for velocity, remember technically that's a displacement. So if somebody goes 20 and comes back 10, your x is just going to be this. Now if that problem says speed, we're going to use 30 for that distance. They'll do the same thing except take this problem. Have somebody do like a vector. If the problem says speed, just add these three components together. If the problem says velocity, technically, there you're going to have to find that displacement. Alright. The three kinematic equations, we know what those are going to be. V equals VO plus AT. X equals VOT plus 1/2 AT square. And V square equals VO square plus 2AX. So we've got our three kinematics. The ideal gas law, number 3. Ideal gas law is PV equals nRT. Pressure, volume, moles, R is a constant, T is our temperature. Number 4, combined gas law is PV over T equals PV over T. It's just a proportion. Now, once again, don't forget the one time they got us by going PV over NT equals PV over NT, because they let half the gas out of the sample. So you had 1.5 for your N's in that problem since they opened the cylinder up. Let's see. 3 equations for power. Number 5. You got power could just be equal to energy over time. Power can be equal to work over time. Power can be equal to F average V. This is the one that lost us the thing one year. So let's try and remember that. Force times average velocity can be a power. And electrical power is P equals IV. Amps times volts. Alright, number 6. A merry-go-round is just IW equals IW kind of question. Where usually what's going to happen is these are going to be your initials, finals. You're going to probably change your I. Number 7, 5 equations for moment of inertia. Alright, let's see. I is equal to mr squared. I is equal to 1/2 mr squared. I is equal to 2/5 mr squared. I is equal to 1/3 ml squared, which is for if you're spinning something through the middle. I equals 1/12 ml squared for rotating something around its end. Question number 8. Kinetic energy, I think we know that. 1/2 mass times velocity squared. Planets of same mass but different radius. The setup on this, here's where this equation comes from, gravity equation. The gravity equation comes from mg is equal to big G, big M over r squared. Because your weight is because of the force of gravity. So if you take a look, mass cancels out. What stays the same? G is a constant, and if you're on a planet of the same mass, M is a constant. So all you're left with is G and R square. So you've got the equation GR square equals GR square. So there's our little proportion equation for whenever we've got planets with the same mass but different radiuses, we can compare their gravities. Question number 10. Hit and stick. M1 V1 initial plus M2 V2 initial equals M1 plus M2 VF. So there's our hit and stick. Alright. Next problem. Number 11. For projectile equations, the only x equation, x equals VOXT, and then Vy equals VOY plus AT, y equals VOYT plus 1/2 AT square, and Vy square equals VOY square plus 2AY. Remember, there's no acceleration in the x direction. Number 12, the range equation. X is equal to VO square sine 2 theta over G. But remember, the only time we can use that equation is if we've got a perfect parabola for a projectile. Any other time, it's out of the way. And remember, whenever you solve for theta, whenever you do your shift sign, you're going to have to come back and divide that by 2. Alright, number 13. Let's see, number 13, Ohm's law. Volts is equal to amps, current times resistance. Famous Ohm's law. 14, series and parallel resistance. Series is R total equals R1 plus R2 plus R3. Other one is for parallel, 1 over R is equal to 1 over R plus 1 over R plus 1 over R plus however many that you've got. 15. Force between charged particles. Coulomb's law, F equals K, QQ over R square. We can use that anytime we've got two charged particles and we want to know the force between them. Give me their charge, give me how far apart they are, and we've got that force. 16, the Lenz equation. 1 over F equals 1 over P plus 1 over Q. Focal length, object distance, image distance. P, B, and J. Your object, 16. 17, magnification. M is equal to H prime over H, which is also equal to negative Q over P. Most every one of y'all didn't do the negative Q over P. Remember, H prime means height of image. That's height of your object. Oops, camera bumping. 18. Force on charged particle in the magnetic field. That's one the bunch of y'all skipped on the test. F equals QVB. Charge, velocity, magnetic field. And remember, your angle is usually going to be 90, so that's just 1. So most time I doubt you even use the sine theta. 19, an elevator. T minus mg equals ma. There's your elevator. Tension minus whatever the way the suitcase is equals ma. 20 centripetal force. F is equal to mv squared over r. 21, top and bottom of the circle. At the top of the circle, you've got like the tension or whatever plus the weight is equal to mv squared over r. At the bottom of the circle, tension minus the mg is equal to, at the bottom the weight is going against it. Alright, next question. Number 22. Weightlessness. Weightlessness is when you've reached a moment at the top of a circle where your weight is equal to, your weight is actually your centripetal force. So those masses cancel. So really weightlessness is just G equals V squared over R is all you've got. Alright, that was 22. (23) Hooke's law. F equals negative kx. Again, I never used a negative, but technically it's in there. 24, center of gravity. Technically, center of gravity. Center of gravity is equal to sum of all of your mx's over your sum of all of your masses. 25. 25 is just like number 9, except here you've got different planets with different mass and radius. Once again, here's your setup equation. mg equals big G mm r squared. M cancels. Now, if the planets have the same mass, that m is a constant. But here the only thing constant is G. So you end up with gr squared over m equals gr squared over m. Or if you want to keep the weight in there, just keep weight r squared over m equals weight r squared over m. You can do it like that if it said something about weight. 26. 5 things that equal mv squared over r. Mu n can be equal to mv squared over r. Let's see. KQQ over r squared can equal mv squared over r. Big G m over r squared can equal mv squared over r. Let's see, other things that can be equal to mv squared over r. Let's see, QVB equals mv squared over r. I'm going to say that's the one most of you left off when you were doing this one. A bunch of y'all wrote F equals mv squared over r. Well, mv squared over r is F. That was just dumb. mg equals mv squared over r. So all 5 of those would be possible good equations for things that equal mv squared over r. 26. 27. Period of a pendulum and a spring. A pendulum 2 pi square root L over G. A spring T is equal to 2 pi square root of, if I can remember it, M over K. (28) Volts stay the same in parallel. Amps stay the same in the series. Only one person got that backwards. 29. Torque is either equal to a force times the radius, or torque can be equal to I alpha. A lot of people forgot that second I alpha one. 30. Rotational kinematics, omega equals omega O plus alpha T. Theta is equal to WOT plus 1/2 alpha T square. W square equals W. Jeez. Crud. Omega square equals WO square plus 2 alpha theta. Number 30. Equations for tangential acceleration and velocity. Let's see. A is equal to R alpha is your relationship between A and alpha. V is equal to RW. It's your relationship between angular velocity and V. 32. Teeter-totter. FR equals FR. 33. Density is equal to mass over volume. 34. 1 revolution is equal to 6.28 radians. 35. Things that bug me. Buoyancy is equal to rho VG, and that rho stands for the fluid's density that you're sitting in. 36. Equation for an object floating in water. Here's the thing. Basic equation for something in water is just B minus mg. That's just a basic equation for anything in water. Next, you need to write rho F VG minus and rho O VOG. And here's the thing. Technically, that's volume fluid. Well, if it's completely submerged, submerged means that VF and VO are the same. Which means really, for something to be submerged, all you've got left is that. And here's what's funny. If it's submerged and these two don't match, the object's either going to be sinking or rising. So that's what it means to be submerged. The volume of the object, the volume of your fluids are the same volumes. 37. Buoyancy when partially submerged. Once again, B minus mg equals 0. The catch, though, is rho AHG minus mg equals 0. And remember, anytime you want to, you can change that mass to a rho O VO in the problem whenever you want to. So this mass is always talking about your object. 38. Momentum is equal to mass times velocity. 39. If something falls, it loses 20% of its energy. That means whatever potential energy it has, final, is equal to 80% of its initial potential energy. 2 equations for Q. Q is equal to MC delta T, or Q is equal to ML. Some of y'all wrote QVC for this. That's talking about charge. We were replying to heat. 41. LF is 80 cals per gram. LV is 540 cals per gram for water. Sum of the Q's for a piece of ice placed in water. You would have a Q to melt the ice. Then you would have a Q for the piece of ice to go from 0 degrees to some temperature final, And you'd have a Q for the water that was dropped in to go from some temperature initial to some new temperature final. 43. Velocity of a wave is equal to V equals lambda F. 44. Speed of sound, 0.6 your temperature in Celsius plus 331. There's your entire front side worth of questions.